A very good morning to each and everyone here. Hope all are safe and doing well. I am Dr. Shanti from Department of CSC CMR Institute of Technology, Bangalore, hosting today's event. First of all, I would like to take this opportunity to thank CMRIT management and AICTE Atal, New Delhi, for providing a platform for hosting this 5 days FDP on Scilab, Scilab and XCOS FOSS alternative for MATLAB and Simulink in online mode. We are grateful to you. The world is full of diamonds and gems, and we are having some of them here today to build this event. With this note, I would like to welcome all the dignitaries and participants for this AICTE Atal sponsored 5 days FDP on Scilab and XCOS FOSS alternatives for a MATLAB and Simulink organized by CMR Institute of Technology, Bangalore from 7th Feb 2022 to 11th Feb 2022. So a warm welcome to you all. It is a traditional ritual in India to light a lamp before beginning any auspicious task, known as Deepak or Jyoti, which represents Agni. The lighting of lamp removes darkness by spreading the Almighty's grace and divine energy in the surrounding. Light also symbolizes abundance, prosperity, and knowledge. We now have a virtual lighting of lamp and declare the program open.
या शुभ्रवस्त्रावृता या वीणावरदण्डवन्दितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमा आद्यां जगद्व्यापिनीम् वीणा पुस्तकधारिणीम् अभयदाम् तारापहा हस्ते स्फाटिकमालिकां विदधतीं पद्मासने संस्थितां वन्दे तां परमेश्वरीं भगवतीं बुद्धिप्रदां शारदा
Thank you, Dr. Manoj, sir, for the wonderful rendering of virtual lamp lighting as a great begin to this event. Let us begin the event with a wonderful quote: "Be the change you want to see in the world," said by Mahatma Gandhi. Yes, as it says, in education system, teachers should first be the change to reflect the change in the student community. From 2 years of suffers with COVID pandemic, we have understood the importance of using open source tools and software in teaching learning process. We have faced a lot many difficulties in using paid software tools specifically while conducting the practical sessions. This has shown us how important for academia to introduce full-fledged use of open source tools in teaching learning process. Hence, this 5 days FDP has main focus on using Scilab and Xcos, an open source alternative for MATLAB and Simulink tools. So now let us welcome, let us start with today's session. We are glad to have Dr. Harish Sahu, scientist DRDO, New Delhi, assigned as Atal FDP coordinator from AICTE for this 5 days FDP program. We are honored to have you as the part of this event. A hearty welcome to you, sir. We are privileged to have Dr. Mohit Tahiliani from NITK Surathkal as keynote speaker for this great event. A warm welcome to you, sir.
Thank you. Good morning.
Yeah. Mohit P. Tahiliani is an assistant professor of computer science and engineering at National Institute of Technology, Karnataka, Surathkal, and a member of Board of India Internet Engineering Society. He has obtained PhD in the area of congestion control mechanisms for the next generation internet from NITK Surathkal in 2013. His areas of interest includes network congestion control, queue disciplines, network function virtualization, deterministic networking, IPv4 deployments, named data networks, and distributed ledger technology. He has executed projects in these areas that have been funded by Intel Technologies India, uh, Bangalore ABB Global Industries and Services Private Limited, Bangalore Robert Bosch Engineering and Business Solutions, and Future Way Technologies in USA. Mohit received the EMC Young Achiever of 2015 award from EMC Corporation Bangalore and the Outstanding Young Professional Volunteer Award of 2021 by IEEE Bangalore section. He has contributed to open source projects for more than a decade. A packet scheduler developed by his team at NITK Surathkal to fight the buffer bloat program got merged into mainline of the Linux kernel version 5.6. He is a member of steering committee of NS3 consortium and a co-maintainer of traffic control and TCP modules in NS3. He served as a member of PC for workshop on NS3 for the past 8 editions. Besides, he served as a mentor for Google Summer of Code, that is GSOC, a global platform. From 2017 to 2020 for the NS3 organization and is one of the organization administrator for 2021. He also served as organization administrator for NS3's participation in Google Coding during 2018 and 2019. He has around 45 plus technical publications in peer reviewed international conferences and journals. He is a reviewer for IEEE Internet of Things, IEEE Transactions on Cloud Computing, Elsevier Journal of Network and Computer Applications, Computer Communications, InterScience journals, IEEE Communication Letters, and held several other roles in IEEE and Springer conferences. He served as a guest editor for Annals of Telecommunications, Springer Journal. He is a senior member of IEEE and was a student activity chair of IEEE Mangalore subsection during 2015 till 2017, secretary during 2021, and member of executive committee of IEEE Mangalore subsection for 7 years. He is currently chair elect of IEEE Mangalore subsection. He is also a member of ACM. We are grateful to you for accepting our invitation as keynote speaker and gracing this event. Sir. Behalf of CMRIT management, principal, vice principal, HODs, staff, and students, I extend a hearty welcome to you, sir.
Thank you so much. Thank you
Now,
for the kind
I
introduction.
request Dr. Mohit Tahiliani to honor the session with his keynote address. Thank you.
Thank you very much. I hope I am visible and audible.
Yes, sir.
Okay. So, hello everyone. Good morning. And first of all, I would like to thank CMRIT management for giving me an opportunity to talk to all of you and deliver this particular keynote address. So, I'm very glad to see that CMRIT has been consistently taking efforts to bring forward the importance of open source tools and is already taking a step ahead in terms of training its students on open source technologies so that they can move forward with their career and know how to derive solutions by themselves without having to wait for commercially licensed tools or not getting restricted due to any other such things. So in this particular short keynote talk that I have to deliver, I chose not to make a presentation for 10 minutes but rather tell you the importance of open source, why is it important, and I'll also give you some important links. So I believe there will be students, there will be faculty members who are attending this particular program. So I believe that these links which I have brought are important for both communities, that is the student community as well as the faculty community. So first of all, I would like to emphasize that open source is one clear road which anybody can take, including a faculty or even you are a student. Many a times as a faculty, students have approached to me and asked me, what should I do next? I have no idea about that, whether I should go to work for a company or whether I should go for higher education. And many a times, many students think that they need to start thinking as early as in second year so that they can prepare for GATE if at all they want to go for higher education or prepare for GRE if they want to go out of India. And many a times they think, okay, let me start focusing on sharpening my programming skills so that I can sit for the placements and I can get a job. But many students are confused. They do not have an idea which road to take. And you take any road, it takes preparations. Even if you want to go for higher education, you should have good projects on your CV. And even if you want to go for a company, you should have sharp skills related to programming, related to the fundamentals of your particular discipline. And when I talk about open source, I'm not referring to only software. Let me tell you very clearly, there is something called open source hardware as well. If you've not heard about it, then you should be glad to know that, for example, phones such as OnePlus are open hardware phones, basically. So there are a lot of open hardware devices, for example, Raspberry Pi or Arduino boards. These are all open hardwares. You can actually literally do what you want to do on the hardware. You have total control of hardware. So when I'm talking here, I'm not referring to a specific community of computer science or electronics and engineering. I'm referring to anybody who belongs to science, engineering, and management and is interested in open world. That means contributing to such areas that people can have easy access to, and open source has that advantage, right? So I have always told my students, you are confused that you should go for higher education or you should go for industry job. The simplest solution is work on open source, because if you can build a CV working on open source, it's going to take you either way. You want to switch to higher education, having an open source contribution is not going to hurt you. And if you have an open source contribution, even industries would like to take you because they know you know the art of writing the programs, or you know the art of working in a big platform. For example, Scilab is a pretty big platform as an alternative to MATLAB, which is the main focus of this particular workshop. So idea is just being aware that there are tools like this and you have some hands-on experience on that allows the industry people to gain more confidence on your profile. So in my understanding, the answer to that very important question, and if you are a faculty, please tell your students that the answer to one question, whether you should go for higher education or you should go for a job, will become clear only when they reach about final year or pre-final year. But what they can do right from the beginning is build a CV in which they have significant contributions made to the open source world. We as faculty members have one important responsibility. We have certain things in our control by which we can make students understand the importance of open source. Let me give you an idea about what I do. So, for example, the course assignments. I have mandated that the course assignments will not be collected on paper. All the course assignments will be collected through digital means, and that too only via GitHub or GitLab. Git is a very important version control system which every student needs to learn today. If they are going to work for any company, just take it from me, any company, they will need to know what is Git and how it works. So having that knowledge, at a very young age is definitely going to be a plus for your students. And if you mandate it to be a part of the course assignment, then they will automatically learn that. And once they learn and they enjoy, it becomes fun for them. They will automatically manage all their projects on Git. And what happens is when you mandate them to use Git and they start learning it, automatically their profile starts building. Let me tell you, most of the companies today do not want to see a PDF of the CV of a student. Rather, they always ask, can you give me your GitHub profile or a GitLab profile? Or can you give me a profile wherein I can see what you are coding? Can you tell me what is your hacker rank? Or can you tell me what do you do in CodeChef? So basically, all these companies are becoming smarter in terms of identifying what have you done in the past 2 to 3 years. Not just what you know, but show us what have you done. And the only way you can showcase these things to your students is that you start making them work on Git or open source tools at the beginning, so that by the end of pre-final year or final year, when they reach to the stage of placements, or for example, the master's students, you can start them from first semester so that when they reach their third semester, even PhD students, it open source is just there for everyone. My profile was being read out. You might have heard about one term that Professor Shanti spoke about. She said about Google Code. What is Google Code? It was a program by Google for 13 to 17-year kids which are in high school. Now that program has been shut down, but that program ran for 10 years. And in this 13 to 17 are our school children. And this was an open source program. The website is still open actually. You can go and search codin.withgoogle.com. I will put up the links later on if you want. But point is that this program was run by Google for 13 to 17 aged kids with the permission of their parents to introduce them to open source. That okay, for example, what is an alternative to Microsoft Paint? We know we have Windows and we use Paint quite often for drawing images. What is an alternative to Paint? Okay, so there is something called GIMP, GIMP. I can go, I can use that, and it's totally free. I don't need to have a paid version of Microsoft Windows operating system to be able to use MS Paint. I'm not saying that we should not go towards commercial license softwares totally. What I'm saying is wherever there are alternatives and easy to use, we should try to leverage so that we contribute and be a part of a bigger community. Second thing that I would like to tell, this pandemic brought in a lot of challenges for many people, and particularly theories were not a problem. Delivering lectures was not a problem. But take for example, now I'm talking to you, it's not a big deal. I'm any part of the world I can be, I can talk to you. But let's say if I have to tell you now to perform some experiments and I want to take a lab session for you, that's where we face challenges in this pandemic. So I would like to mention that there are lots of open source alternatives that already exist, but some of us we are not aware that they are there. So I will just like to share with you Let me try to share the screen and see whether I get a chance to do that. I'll show it to you. I have some tabs open, so maybe somebody can confirm when you are able to see my screen. Is
Sure.
my screen visible?
Yeah, it's
Yeah.
visible.
Yes, it is visible.
Yes. So this is vlab.co.in. Unfortunately, the chat option is not enabled for me because maybe I'm outside of CMRIT organization's email address. So, but vlab, that is virtual lab, vlab.co.in. If you go here and just see what they have done, it's totally funded by Ministry of Education. Earlier, it was called MHRD. It is under the National Mission on Education through ICT, NME ICT. And if you go down and see, broad areas of virtual labs, they have labs in almost every discipline. You can see, including physical sciences, chemical sciences, and mechanical engineering. So, if you go to these example, let's say I will go to computer science because I belong to that stream. And you can go and see there is BLSI lab, computer organization, data structures lab, which is built by IIIT Hyderabad. So if I go to this data structures lab, of course, it might have changed the tab for me. You might not be able to see that tab, but all animated explanations of, merge sort, or, for example, stacks or queues, wonderful sets of experiments are available, which you can pass it on to your students and they can actually perform it live. I also want to show you one very interesting thing that Government of India did, and fortunately NITK is a part of that, is something called remote triggered labs. So let me open up that website that is called RT Labs. RT stands for remote trigger and labs means laboratory .nitk.ac.in. So you can always go back to the recording of this session and listen to these URLs. But I hope this screen is visible right now, the one that I'm showing.
Yes, sir.
Yeah. So you can go to this RT lab and you can go to, for example, this vibration lab, and you can see there are 7 experiments in this. Let's say we go to a reconfigurable pendulum. You can see there is a theory associated with reconfigurable pendulum. So you can see this is not basically only for computer science. This is also something that our first year engineering students study. The necessary equation, the procedure to conduct this lab is explained here, how you should conduct the lab. Then you can also take a quiz for yourself. And then the most important is remote trigger. This is very interesting. Remote trigger means that sitting from any part of the world through an internet connectivity, you can trigger an hardware and the hardware will actually get triggered. Okay. So that means if you go, for example, I'm from NITK network. So I'm selecting NITK network and I'm saying start. And then I will say live stream. It will take some time for live stream feed to come. This website is currently being revised. This has been running since 12 years right now, and we have recently revamped its interface and everything. So it will take a moment, but it will come. After that, video comes, and then you see this red color button, which is called trigger. When you trigger, here in this video, you will see the actual hardware pendulum getting triggered because you just click the button here, it will trigger. And below, you will get a total graph of frequency over time. Because when pendulum oscillates, there is a frequency that the student has to calculate. Now, let's say you completed that one experiment, and after that, you want to change the length of the pendulum. Let us say you want to increase the length of the pendulum because the frequency of oscillations would also be dependent on the length. So you can actually change the length of the pendulum and then trigger again. And then you will see that now this time the frequency of oscillation was different. And we give an option where you can download the data and do offline processing. We also give an option that, let's say, Mohit is performing this experiment right now, and Professor Shanti also wants to perform this experiment, but 2 people cannot have control on the hardware. So what we do is, if I'm already performing the experiment, I will this system will put Professor Shanti in wait mode. But the beautiful aspect is that while she is in the wait mode, she will be able to see what experiments I'm performing, and she will also be able to collect the data of the experiments that I'm performing so that she can save her time and she can get the data and start working with it, basically. So please try such kind of things. These things, let me tell you, were not made after pandemic. This is a project that is running since 2006. So virtual lab project, which I told you, and RT labs. So you can imagine these are totally open source solutions. No payment, no licenses, no login. The most beautiful part is there is no login also. You don't need to create an email account or you don't need to do anything. And not just computer science, there are a lot of labs which are related to mechanical, electrical, civil, and you can see how they are done. Even pharmaceuticals. There are labs related to pharmaceutical. Forget about that. There are labs to teach you English. Okay. So if you think your English is not that good, you can actually go take a virtual lab to teach you English. So, and basic sciences like chemistry, physics, labs are there pretty much for all the things. And this is something that government of India started in 2006. Not that they predicted the pandemic, but the idea was many institutes in India still do not have proper infrastructure. So imagine instead of investing on infrastructure, you keep buying licenses. So instead of buying licenses, it would be better if you could put more infrastructure. But government of India knows that there is not very good infrastructure that everybody can afford. And that's why these labs were made so that anybody, a part of India or even abroad, can get access to education, can get access to laboratories for free. Even hardware is remotely accessible and you can use it for free. Let me tell you one very interesting thing. One of my PhD students who recently graduated from NITK, he did his entire work on IoT. And let me tell you, I did not buy a single IoT device at NITK. But still he completed PhD because in France, there is a lab which is called Fit IoT Lab, totally free of cost, openly available for anybody. 2,700 IoT devices can be controlled remotely from your laptop sitting here in India. So what my PhD student did throughout his PhD is he connected to this lab remotely, and whatever number of IoT devices he wanted, he used to book it in advance, like few hours in advance. Then he used to get access to those hardware. He will play around with that hardware for 3-4 hours, perform his experiments, collect the results. Next day, again perform experiments. He did not have to even buy a single piece of hardware. And imagine if it was pandemic. I mean, of course, he had completed all his work by pandemic, but if it was pandemic, even if he wanted to access his hardware in the lab, it was not possible because college doors were shut down for anybody. Nobody can come to the campus. So, because of this remote facility, he was able to continue his experiment as if like nothing happened. So, let me tell you that this open mentality or open source world is growing very fast. And let me tell you one last thing before I close in the next 3 minutes. Earlier, we had funding opportunities from Government of India. Now, besides the funding opportunities from Government of India, there are many other opportunities if you are working particularly on open source. So let me share one thing which is particularly for students, but even faculty members can take benefit out of it. So I would just like to open this and all these links. If you are not able to get it, not a problem. So you can see this summer of code programs. There are nearly 37 plus summer of code programs where your students can participate. And you can see most of them have stipend provided to them. You can see. So the timeline of each event is here. Professor Shanti was talking about my participation in GSOC, which is Google Summer of Code. But you can see there are 37 plus programs where your students can participate and they can get stipend. That is one source of funding. Second source of funding is Mozilla Technology Fund. Mozilla Technology Fund recently concluded a call for proposals, which was for 50,000 US dollars. That comes to nearly about like 37 lakhs. And it was a 1-year project. That's it. So imagine funding available on open source. So if you are a champion at open source or if you are contributing to open source, plenty of funding opportunities are available and you should definitely grab that opportunities. So I have delivered many other talks. Maybe sometime else I will talk to again all of you. I have dedicatedly given 1 hour of time just to talk about what are the different websites where you can go and ask for funding for open source. And funding for open source is pretty lenient because you're contributing to the world. The impact that you make is pretty huge. If you contribute something sensible, a lot of people are going to get benefit out of that tool. So open source funding is more lenient and they are much more structured. So why not use those kind of funding opportunities? So with this brief information, let me summarize what I spoke about. I told you what are the different kinds of open source benefits. For example, the virtual labs, for example, the RT labs. I told you what are the problems that you might face if you go for the licensed software. And at the end, I told you these are the open source programs where your students can participate. And lastly, I touched upon very briefly, there are plenty of funding opportunities. Like I told you, if you just Google search Mozilla Technology Fund, or for example, you search Mozilla Open Source Software, you will find a lot of information about these things. So I would want all of you to take maximum benefit of this particular session. There is also a very beautiful website and initiative by IIT Bombay. I'm sure you might have heard about it. It is called FOSSI. I believe my screen will be visible to you in a moment. So if you go to FOSSI, and if you look at their first project itself is Scilab, which you guys are all going to discuss today. So IIT Bombay FOSSI team has been contributing very significantly to Scilab. And there are lots of internships opportunities for your students which belong to, 1 semester long internship, or you can just send them for summer internship. So all these opportunities are available. So take maximum benefit out of these initiatives that CMRIT has taken. And I would encourage all of you to make use of these 5 days. I'm sure a wonderful set of resource persons are going to talk to you over the next 5 days. I hope this program a big success. Back to you, Professor Shanti, and thank you for giving me an opportunity to talk to all the participants again. Thank you very much. I hope I was audible.
Yes, sir. Yes, sir.
Thank you.
ஆமாங்க சார்.
எனக்கு முடியாம ஃபர்ஸ்ட் இருந்தா பையனா முடியாம வந்து வீட்ல இருக்காங்க. அப்ப இருந்தது. அப்போ நான் வரணும் தான் கொடுத்தேன். இங்க யாரும் வரக்கூடாதுன்னு எனக்கு பிளாக் பண்ணி வச்சிருக்காங்க. அப்புறம் அன்னைக்கு நன்றி புலவர்தான். யாரோ ஒருத்தவங்க வரல. எல்லாரும் ஆஃபர் இந்த பேருக்கு எந்த ஒரு மிக அதே பேருக்கு 70 இருக்கு.
I believe there is some problem from the organizer's side. They are probably not able to hear us.
Yes, sir. Even I just wanted to say that the settings are like that anyone can remove you from the meeting and anyone can unmute yourselves. So if organizers are listening, if they can change this setting, I think it will be good for the participants also.
No, yeah. So let me just try to call them over the phone and give the floor. Just give me a minute. I'll reach out to them through other means.
என்ன எதுவுமே பண்ணாம எப்படி இருக்க முடியுமா சார் லீகல் இல்லையா சார் லீகல் இல்லையா இங்க எங்க நம்ம முடிஞ்சிருச்சு நமக்கு ஸ்டோர்ல இல்லை சரி நான் அனுப்புறேன் எனக்கு அதுதான் ஒரே இதா இருக்கு உரிமை இருக்கிறதா ஒண்ணுமே தெரியல
நம்ம பசங்க சண்டை போட்டுட்டு இருக்காங்க குரூப்ல. இவங்க ஆன்சர் போட்டுட்டு இருக்காங்க இல்ல இந்த குரூப்ல. இதுல வந்து அண்ணாஸ் வந்து
ஹலோ
அப்புறம் ஏன்டா இந்த குரூப் டெலீட் பண்ணுங்க இந்த மெசேஜ் பண்ணா இதுல மெசேஜ் பண்ணாதீங்கன்னு சொல்றான்.
All right, so participants, I just got the information from the organizers that there has been some internet connectivity issue and the organizers will be joining back in a moment is what they mentioned. So having said that, we can utilize this time until the organizers come in case you have any queries or any questions about the things that I mentioned to you. In the meanwhile, let me open up another very important link in case anybody is interested to work on blockchain based technologies. I will just share one important page where you can find a lot of funding opportunities and you can actually apply and get some funding for your work. So I believe my screen will shortly pop up and you should be able to see something called Algorand Foundation. So we know Bitcoin is very popular, that uses one blockchain technology. There is another one, Ethereum. This is yet another one, which is from an MIT professor, and it's picking up the market rapidly. So if you go here, you can see there's something called grants program where you can see what are the research proposals you can write, or if you are developing a tool, how can you contribute, or if you are related to an education community, which I think most of you are, you can see what you can contribute. But besides that, you can also go to the ecosystem and go to the education, and you can see on the left hand side there are dedicated university programs, developer education courses and certification. So let me take you to the university program. You can actually apply as a university to Algorand and then you can get funding. So you can see some of the best universities like University of California, Berkeley and all have already joined this program. So you can fill up this form and they will get in touch with you and you can start working with them. Similarly, there's developer education available and you can go and find out what are the events that they are conducting, what are the hackathons they are conducting, accelerator programs. Let me also show you the education and community grants program. So if you scroll down, you can see there is an algo grants program funding, or there are community bounties, and then these two are not active at this point of time, but you can still see that these two funding programs are active and you can actually apply. So this website itself, if you take a minute to, take time to scan, will require about like maybe half an hour, 1 hour to go through all the different funding options that they have. You can see here funding options. There are 3 options open here. So each page has different funding options available. It depends on you as to which particular funding option you would like to use. In this one, there is only one open right now. So please make use of such kind of things. Let me also take a minute to share about the Mozilla Technology Fund, which I was mentioning. They had opened up a program for AI, and they said up to 50,000 US dollars worth of funding will be given, provided you have a tiny prototype that is available. And look at the word. I'm going to share the website. Take a look at the word. They very clearly say only open source communities can participate. So that's the significance at many places. You can see this. This is called Mozilla Technology Fund, and it says it supports open source technologists whose work furthers promising approaches to solving pressing internet health issues. So if you see this, it's mainly for open source enthusiasts. And they said that $50,000 each to open source technology projects, which can make artificial intelligence systems more trustworthy. And they have given a theme. So in that theme, if you are working on certain aspects, maybe you are eligible to participate in this kind of program. So of course, the deadline for this program is crossed. Give me a minute. Yeah, so I was saying that of course the deadline for this has crossed right now. I think the deadline was 4th November, but of course these programs will again open up after one round. So totally they had 300,000 US dollars for each project. They were giving 50,000 US dollars. That means 6 projects, each of 50,000 US dollars were awarded, and the results will be out sometime soon. So like this, let me tell you, if I keep giving you this session maybe for another 1 hour, there are plenty of other opportunities related to open source where you can apply. Even Nvidia has started accelerator program for hardware. So if you want some hardware like GPUs, or if you want some hardware for processing, you can always reach out to Nvidia's website called Nvidia Accelerator Grants Program, Hardware Accelerator Grant Program, and they will gift you certain hardware. and you don't have to actually get involved in any payment issues or license issues, right? So these are certain things that I wanted to share, and I believe now the organizers have joined. I can see Professor Shanti has joined. So just wanted to utilize this surplus time that I got for you to make the best use of this opportunity of these funding programs that are available. Professor Shanti, can you hear me now?
Yes, sir.
Yes. So thank you very much for
Thank
giving
you.
me an opportunity. I hope I was able to add a little bit of information for the participants today.
Thank you so much, sir. Once again, we are sorry for the inconvenience because we have disconnected for a while from the net. So just we are back. So thank you so much for enlightening us with this great insightful session, sir. You have highlighted the importance of open source contributions, its benefits for students as well as faculties, various opportunities in open source contributions, and different global level platforms and competitions, which can be used by both students again and faculties. We are glad to say that we are also associated with the NITK and IITB FOSSI in the implementation of virtual labs. So because of pandemic, COVID pandemic, we could not continue in the implementation of virtual labs during these 2 years in between. We have started working uh, with the coordination and guidance of professors from NITK and even taking the help of IITB professor coordination. So we will continue now once again with these features, so that surely it will be going to be a great platform to learn the projects, practicals for the students uh, by overcoming any kind of such problems what we have faced in the last 2 years. Thank you so much for making some time with to spend with us besides your busy schedules and gracing this great event, sir. Thank you once again.
The pleasure is mine. Thank you and wish you good luck
Yes, sir.
for the workshop. Bye bye.
Thank you, sir. Thank you, sir. Moving forward, we will be having day one session on Scilab programming by a renowned resource person, Dr. Mahesh Anand, sir. Dr. Mahesh Anand is the founder of Scientific Computing Solutions, SES India. He has 18 plus years of experience in academics and corporate training, trained over 40,000 plus professionals across India on various skills including data analytics, machine learning, deep learning, signal and image processing, computer vision, pattern recognition, and soft computing using tools like Scilab, MATLAB, SAS, R, Python, OpenCV, Hadoop, Spark, and different big data ecosystem. He is a senior consultant for various AI-based companies and startups, including Matt Street Den, Qubit AI, IMD, CLRI, First American, CGI, NGA HR, and leading edtech and higher education institutions across India. He was a recipient of an AT&T Labs award from IEEE headquarters, New Jersey, USA, and MV Chauhan Award from IEEE India Council to his credits. He authored more than dozens of research papers in national and international journals. He is the founder of a 10-year-old analytics consulting startup, SCS India, and serving AI-based solutions to their clients in healthcare, NDT, meteorology, e-commerce, and retail verticals. On behalf of CMRIT management, principal, vice principal, HOD, staff, and students, I would like to extend a warm welcome to you, sir.
Thank you very much for your kind introduction. Very good morning to
So,
all participants.
thank you, sir. Let us now start with today's session on Scilab. I would like to hand over the session to Dr. Mahesh Anand. Over to you, sir.
Sure, ma'am. So once again, very good morning, all of you. And I thank CMR IT for inviting me as a resource person for this 4-day long FDP. So if you look at the content, how we have planned these 4 days, I hope everyone are able to see my screen, right? I have shared the screen.
Yes, sir. Is
Yeah,
it
great.
visible?
Yes, sir.
Yeah, great.
Sir, if it is made full screen, probably it will be more clear.
See, our focus on day one, I would like to concentrate on the foundation and basics. Mainly, the mathematics I would like to touch upon. The linear algebra as a core and matrix formulations and linear algebra. Whatever the applications we are going to go through from tomorrow onwards. So the key application area I'm going to touch upon in this FDP are one is the signal processing. As you see, the day two content is focused on the signal processing, mainly on time series data, one-dimensional time series data. So some of you are working in biomedical signal processing, or you may be working on the speech signal processing, or in any sensor data. If you are into instrumentation related domain, you may be working on various sensor data, whether the sensor picks up atmospheric pressure, or it can be simple, even a temperature sensor. All these sensor based data are a time series format. So the second day focus will be on how to handle these kind of data and how to analyze these kind of data and what kind of models can be used for these kind of data. Mainly to the focus of towards the last day, if you see our key focus is on, we'll end up with machine learning application. Even today, the keynote, the first talk you have seen about blockchain. See, the next 20 years is going to be the three major technology which is going to rule the whole technology fraternity. Number one is artificial intelligence. Number two, which is blockchain. Number three, which is IoT. So all three has to work in synergy, integrated to each other. And we need IoT devices to pick up the data, mainly from the sensors, which is connected through internet, and which is going to act as a source of data pooling. So your all the major IoT devices is going to be the source of data. Once we pooled the source of data, the next step is to we need to understand, process, understand, and we have to draw meaningful insight from the data. So for that, we need a strong analytics followed by prediction models, artificial intelligence model. So that is the another core. And we need for all these process, we need a data security. And your blockchain is going to provide that data security. So all these three are going to work in synergy. So that is going to be the future next 20 years. These three technologies going to roll over. So out of these three block, my focus will be on artificial intelligence part. I'm not going to talk anything about IoT, either I'm not going to talk anything about the blockchain. So my focus will be on the artificial intelligence. So as you see the content is framed in such a way that we'll be dealing with the different format of data. If it is a time series data, how to process and how to prepare the data for the artificial intelligence model. Of course, we do some bit of simple processing and analysis, both in the time domain and frequency domain. You will understand how to process the data in time domain and frequency domain. And more than processing, how to prepare the data suitable for the artificial intelligence model. So that is our the main objective of the whole idea of this, the 4 day. Finally, our journey will be moving towards the artificial intelligence model. And day 3 will be focusing on the another type of data, image data. You are familiar with image data. So irrespective of your discipline, definitely your image data will be prominent in almost every area. Whether you work with medical images or, uh, as ma'am was introducing about myself, you could have heard that NDT, non-destructive testing. Many projects I have worked with structural engineers and the structural scientist, mainly in Chennai, we have a lab called SCRC lab, Structural Engineering Research Center. So there we get a two-dimensional profile of a concrete structure. You can get the two-dimensional imaging profile of metal surfaces to understand the structure inside the concrete, whether the reinforcement is strong or weak, or any cracks or voids is there. So from the image data, it is possible to analyze. And once we have analyzed, we can capture that information in the form of, we have to transfer that information in the form of a feature matrix. And we can train a machine learning model to understand that feature matrix. And any future abnormality is there in any surface, a concrete surface or a metal surface. So they have a handheld device, something called ultrasound scanner. Like how do we do the ultrasound scanning for our anatomy, human anatomy? Similar manner, they use a handheld device to capture the images. From the images, they try to understand the patterns and features. And using a feature matrix, we have to train a machine learning model to classify whether it is a healthy structure or it is an abnormal structure. See, the fundamental idea, if you look, irrespective of whatever the application I do, whether I do this application, develop this application to healthcare using a medical image, or if I use this application to the non-destructive testing to the structural engineers, or if I use some weather data from the radar imagery, and I do the prediction for some abnormal weather conditions. See, the domain to domain, your image is going to be different. But ultimately, once you have the understanding of the basic image and understanding of the pixels, and understanding the spatial domain characteristics, understanding the frequency domain characteristics, irrespective of the applications, the process remains same. See, at the end of the day, because at many places, the first question people, mostly the audience will ask, sir, I am from so and so department, and in my department we use this image, whether this algorithm will work for this image. See, only your data is different, but the procedure, the mathematics, whatever you are going to apply to the images, at the end of the day, whatever your image comes from, whichever the source it comes from, whether it's a CT image or it's an MRI image or it is a radar imagery or it is an NDT image, at the end of the day, for us, for engineers, it is a matrix of numbers. Please don't ever forget that. So don't worry about which department are you from or which domain you are working in. At the end of the day, each and every problem you just look at as a matrix of numbers. Once you understand the fundamental formulation mathematics of the background of how to process the image and how to prepare the image data for a machine learning or artificial intelligence model, and once you understand that core, you can almost apply that idea to any domain irrespective of your field. So that is why I hope this participant, I have a hybrid mix of audience from across the departments, computer science, ECE, all circuit branches, even civil and mechanical engineering. So almost every field we encounter a one-dimensional time series data for the NDT or imagery data for analyze and understand the data to build a machine learning model. So day 3 focus, if you see, we are focused on understanding completely two-dimensional data. So how to process and prepare the data suitable for the artificial intelligence model. So once you are familiarized with one-dimensional data and two-dimensional data, so our final day, the 4th day, Thursday, will be focusing on what are the essentials to construct an artificial intelligence model. So what are the different categories we have? Like what is mean by a regression model? When we consider a prediction model as a regression model, when we consider a prediction model as a classification model. These foundations, please remember to make yourself confident and expertise in machine learning and artificial intelligence. My strong recommendation is you should have a good knowledge in statistics and probability background will help you a lot. Of course, the linear algebra and matrix formulation, whatever we are going to discuss in the day one, that also going to be helpful. And whatever some few of the mathematic concepts I'll be discussing today, it is going to be applied on, you'll be appreciating this application towards the fourth day in the machine learning model building, either in terms of data transformations. Okay, why we require data transformations, why the data is not readily available. If I present a complex data to a model, what are all the challenges, and what are all the various way to transform a data from one domain to another domain, what is the purpose of such transformations, how such transformations in turn will help a machine learning model to understand the data in a better way, everything you are able to appreciate. So each and every mathematics, whatever we are discussing, the foundation, it is going to be indirectly helpful in all the subsequent part, whatever we are going to discuss, either in one-dimensional signal processing or two-dimensional image data preparation, and finally towards the machine learning and building an artificial intelligence model. So this is our agenda. So I hope everyone have this schedule with you. Okay, we'll stick on to the schedule and we'll try to match with this schedule as much as possible. Okay, so you can see the first one till your first coffee break, right? We are going to understand some basics aspect about how to handle the scalar, vector, and operations, because at the end of the day your data is nothing but a row vector and a column vector and matrix formulations. So even in MATLAB, many of you are familiar with MATLAB, and I will say that almost 95% of uh, uh, the process and characteristics whatever you do in MATLAB and Scilab, they are almost the same. 90 to 95% they are almost the same. Only I can say hardly there is a 5% difference is there. Even you can start experiencing, and moreover I would suggest you see between MATLAB or Scilab, definitely I can give a green signal and strong recommendation to Scilab. Number one reason, first of all, it is an open source. Okay, that is a core agenda of this FDP. We wanted to promote open source. Number two, it occupies very less memory comparable to a MATLAB. Even when you install this Scilab, you could have experienced the whole Scilab, even the latest version, it get installed less than a minute, not even a 60 seconds. But you just try to install MATLAB, it will take a 45 minutes to 1 hour. A massive difference. So it occupies less memory. It's very compactly designed, and of course, see, uh, one is a proprietary licensed product. You are going to spend a lot of money on the MATLAB. Another one, something is getting on free of cost, open source. In terms of the computational efficiency and optimization, still MATLAB having a slight upper edge over Scilab. There is no doubt at all. But whatever the basics need to be done, right? For example, if I take a Fourier transform, or even if I take a covariance matrix, or if I calculate eigenvalue, eigenvectors, MATLAB also going to return the same thing for me, and Scilab also going to return the same for me. So there is no difference. Where you can see the differences in little bit on computational, in terms of computational speed and optimization, MATLAB will be slightly upper edge over Scilab, there is no doubt. But still, whatever the maximum benefit we can extract from the Scilab, definitely it is possible. Till you publish a research paper, more than enough Scilab you can utilize for uh, developing various applications ranging from communication system, signal processing, image processing, machine learning, and stuff like that. But having said that, working with various industries for developing AI based models, and also I'm offering a training program to the working professionals, or mainly the people working as a data scientist. So most of the data scientists working in the industry, that also we see across the globe, the, the industry standard and the popular open source package to develop AI based model is Python. Uh, though we are going to appreciate certain things using Scilab, just being as part of FDP, we have to learn Scilab open sources. But moving forward, as you wanted to take this forward for further for your research, or when you wanted to teach and disseminate this knowledge to your own students, I would strongly recommend in the long run, okay, you cannot settle with Scilab itself. You have to migrate to Python and you have to develop your expertise in the Python. Across the globe, even MATLAB, I can say across the globe, the AI based applications, they are less than 5% occupancy, even a MATLAB. Even that is the condition for the MATLAB, then think about Scilab. The Scilab utilization is even less than 0.5%. But I'm not discouraging using the Scilab. Okay, Scilab you can learn as an alternative to MATLAB, but I cannot recommend Scilab as an alternative to Python, because Python is dominating across the world in all the AI based applications. Okay, so if you wanted to develop your expertise further in AI and machine learning and stuff like that, you have to move forward. Apart beyond the Scilab, you have to learn Python, followed by, for the deep learning applications, we have more specialized APIs called TensorFlow, or very popular Keras API. These are all the tools. They are all open sources. The good news is they are also open source. But these open source are dominating across the globe in the AI fraternity. AI fraternity. And in fact, Python open source is more reliable, and it's highly faster, and it's highly optimized in terms of programming, or in terms of the memory utilization. It is far better than Scilab. That is the reason people were utilizing Python for AI based applications. Okay, so however, this FDP is focused on the Scilab. So our intention is to learn all these technologies with using the Scilab tools. So first you get exposed to Scilab and get understand the stuffs. In the long run, I recommend you to learn Python. That is my kind request at the beginning itself, because you cannot survive on the long run with Scilab. As we move forward, I'll tell you, mainly when we reach fourth day, I will tell you what are all the challenges while designing these models in Scilab. What are all the challenges and how it will take more time, computational challenges and all. It's there. There is a limitation in the Scilab. So with the existing limitation, what best we are going to extract from the Scilab, that is what we are going to appreciate in this 4-day FDP. Okay. So with that note, let me give you some inputs regarding the installation procedure. All of you had experienced the installation procedure. So from scilab.org, if you go, okay, the scilab.org, if you go, and I hope the latest version Scilab exe file, whether your system supports 64-bit or it's a 32-bit, respective exe file, you could have downloaded it. The downloading, it will take less than a minute. And if you double click, it will ask few very basic questions, uh, accept the agreement, and you give yes for everything. At least 4 or 5 windows will pop up. You just give yes to everything, and within less than a minute, the whole installation process will complete. As soon as the whole installation process completed, okay, your Scilab window will open like this. So it will ask you to create, whether shall I create a Scilab icon in the desktop. Just you give yes and give finish. The moment you give finish, it is going to open the Scilab, and your Scilab screen and the Scilab console looks very similar to MATLAB, isn't it? Your MATLAB also, you have the middle, we call this a command window here, but in Scilab language, we call this middle portion as a console. And in MATLAB, we call this right hand side portion, we call workspace, but here in Scilab language, we call that as a variable browser. The moment I say clear, you can see I got some variables have already been defined here. Okay, say for example, this capital D, you can see it is a matrix of size 32 by 11. And again, there is another matrix called DAT DAT, which is dimension 33 by 12, and so on. So the moment I say clear statement, you can see everything is being flushed out from the memory, from the workspace. So variable browser here. And also you can see the command history also, you can see this portion. And in the left hand side, your current working folder. So by default, whenever you opened, let me exit this and I'll show you, I'll open Scilab from the beginning. You can see how Scilab is getting open. As you double click, once you finish the installation, as you open Scilab, so for me, you can see, for me, additionally, there are two more extra toolboxes is getting loaded at the beginning. Okay, for you, it may not show. I will tell you step-by-step procedure. Whatever the extra toolboxes we needed, we have to activate, install, and we have to activate. By default, it will not enabled. Okay, so your basic Scilab will be there always. The moment you open Scilab, install and open Scilab, only the basic. You can make use of Scilab for all the basic matrix computations, vector
Sir,
operations. Yes, yeah.
shall we can display the slides, sir? We are not getting any slides.
I'm not displaying any slides.
Huh.
You're able to see the screen? Scilab
I am
screen?
able to see the screen. I am getting your name only. We are not getting your slides.
I have shared my Scilab screen. You are not able to see my Scilab screen?
No, sir.
So
What
we are
about
able
others?
to, so we are able to see the Scilab screen.
It's visible to
Yeah,
everyone.
it is a visible, sir.
Hmm. Please
I'm
check
sorry.
your option. Why it is not visible for you? Kindly please check.
Okay. Okay, sir. Sorry to disturb you.
Yeah, yeah,
Okay.
yeah. See, as soon as you open your Scilab software, if you see your current working directory in the left hand side, you can see users Windows documents. That is the default folder it get open. Okay. But my advice is, uh, you see where your Scilab is being installed. Generally, your Scilab, any software, whenever you install, it get installed in C program files, isn't it? C drive program files. Inside C program files, any software or any applications, any app you install, it get downloaded there. So your working folder also, my recommendation is to create your working folder for this 4 days, whatever the exercise you are going to work. You keep all the exercise by creating one folder for this FDP. Okay, any name you can create it, Scilab FDP or CMRIT FDP, any name of your choice. So this is a common rule for MATLAB as well as Scilab. Whenever you create any file name or folder name, it is better avoid using hyphen and blank space as a general good practice. So even if you create a file name also, don't leave two keywords. Okay, instead of using two keywords, better you connect the two keywords by underscore. Don't use hyphen or blank space. Avoid hyphen and blank spaces as a general rule, both in MATLAB as well as Scilab. So if you even you can give two or three words, and better you connect that with the underscore. So I have already created one folder for this workshop in the name CMRIT FDP. Okay, let me show you where I have created that folder. If you see this icon, if you click this, you can go back and you can navigate the folder. First, you go to the root drive, which is C drive. If you click this, it will take you back, and you go to the C drive, C colon. From C colon, you start navigating, okay, the location of Scilab folder. So I go inside program files. I just double click program files. So inside program files, you can see Scilab 6.1.1. That is the latest version I have downloaded and installed. I recommend you also to install that latest version, 6.1.1. Double click this. Okay, inside Scilab folder, I recommend you to create your work folder. Okay, um, if I right click, if it is a MATLAB environment, I can simply do a right click and I can create a new folder. But unfortunately, Scilab, we don't have that. Is certain things, they are comparatively less user friendly, but because for that reason we cannot avoid open sources, right? With the available limitations, we are going to appreciate how best we are going to utilize this open source as much as possible. After all, at the end of the day, it's a free of cost, whereas you have to spend lakhs for MATLAB. So we have to compromise certain aspects like the comfort, luxury, and the user friendliness. Okay, but what is the basics requirement is there? Yes, all the basics will be there, but you cannot enjoy that comfort, luxury, aesthetics. That aesthetics, even when you do the plotting and all, the plots and graphs will not look so fancy like how it is being displayed in MATLAB. Comparatively, will be less fancy. Having said that, less fancy, you will get the same graph, you will get the same interpretation, but the layout and all, it looks very simple and very minimalized approaches. So these are all the factors you have to compromise. If you compromise, if you're ready to compromise on these aspects, definitely you can appreciate Scilab to the maximum benefit. So if you wanted to create a new folder here, the best way to create it through your you have to navigate through your folder browser. So from here, my computer, from here you can navigate, okay, program files, inside program files, Scilab. Now you can create a right click, okay, and create a new folder. You can create a new folder, like you can name it like a CMR FDP, okay, any name, whichever the way you want. You can create a folder. So I have already created a folder. Okay, so let me delete this folder. So I have kept a folder in the name CMRIT 7 to 10 Feb 2022. You could see CMRIT 7 to 10 Feb 2022. So I have created this folder. So from your Scilab window, okay, whichever the folder you have created, you just go inside that folder. Okay, so I have created the CMRIT 710 February. So this is my current working directory. As soon as you entered this folder, okay, just you put CLC to clear the screen and clear for clearing your variable, whatever you have created. For example, see from the console, I just create a couple of variables, a equivalent to 10. It is a scalar, isn't it? It is a scalar, 1 cross 1 dimension. Suppose you wanted to create a vector. I create a vector like a row vector, 9, 10, 4, 5, minus 2. So this is a row vector. So by default, you can see your row vector, it is a 9 dot 10 dot. That means the default data type is double. The moment you define a numerical data, by default, Scilab will take it as a double data type that you can see in the variable browser. So you can see the variables have created. If you don't put anything in the left-hand side, okay, if I don't say anything in the left-hand side, by default, okay, the assignment will go to a variable called answer. Say when I say ans plus 10, any operation you do with ans, okay, the default variable is ans. The row vector is being assigned in ans 9, 10, 4, 5, minus 2. When I say plus 10, each and every element, it is adding the value 10. So my suggestion is never you leave blank in the left hand side. Always you assign a variable and get the result. Don't uh, store any results in the default variable ans. Because if you leave your answer in the default variable ans, what happen? No, maybe your next assignment, something else you define like a column vector. Whenever you define a column vector, same procedure like a MATLAB. There is nothing different. Each and every element should be, you should end up each and every element with a semicolon operation. The moment I close this, now you can see I have created a column vector. The size of the column vector is 3 by 1, right? 3 row, single column. Whereas the size of this row vector is 1 row, 5 column. 1, 2, 3, 4, 5. 1 by 5. This is 3 by 1. Now you can see my ants get automatically updated with the latest assignment, whatever. Now if I display ants, it will show me a column vector 453. It will overwrite over my row vector. So earlier ants was storing this result, isn't it? And ants was storing this result. Now, whatever the latest assignment, your ants will store. So that is the reason, never leave your left hand side blank. Always assign some variable and get the result out of it. This is some of the common aspects between even MATLAB or Scilab, the same rules and procedures that you should be aware of. So CLC, just to clear your console, and I use clear to clear the memory, your variable browser. So the moment I say clear, everything got cleared. So initially, I hope you got nothing inside your folder, whatever you have created. Your folder looks empty. Okay. Shortly, the organizers will share few data files that you are going to work with day 1 and day 2. So almost the files required for day 1. Day 1, we may not require any external data files till 4 noon. Only after the lunch 2 to 3:30 session, I'll be introducing how you can access some external files. If it is an XLS file, how to load an XLS file. If it is a CSV file, how to load a CSV file. If it is a .dat file, how to load a .dat file. If it is a .txt file, how to load. So different file formats in Scilab environment, how to load. So the loading process is completely different from MATLAB. That file input output operation is the portion. We have a massive difference between Scilab and MATLAB. But otherwise, the computations you are going to do, in which the array assignments or the matrix assignments, the indexing, the basic formulations and operations and all, that portion remains 90% common. But where you can see there is a major difference between MATLAB and Scilab is what? The file input output operation. The way in which I load an Excel file in Scilab may not be same as MATLAB. In MATLAB, we have a completely different function. So that way, there is a huge difference between Scilab and MATLAB. So we have to focus and we have to give special attention towards that, how to load a different kind of data files into Scilab. And another unique difference in Scilab when compared to MATLAB is, in MATLAB, when you type pi means, it will understand in a command prompt. If I type pi 22 by 7 3.14, MATLAB will recognize what is pi. Suppose you can directly say that 4 into pi, you can operate 4 into pi in MATLAB, it will show you the result. But Scilab will ask who is pi. So there are some special characters in Scilab that has to be declared with a notation called percentage notation. That is another unique difference. So for example, pi, I have to specify with the percentage symbol, percentage pi, then Scilab will understand. Otherwise, it will ask, it will treat pi like a variable. But in MATLAB, there are some special variables we are not supposed to use as a variable declaration. But here in Scilab, because Scilab does not understand what is pi, okay, even if you take pi equivalent to 50, it will treat pi as a variable. But in MATLAB, it is not recommended to declare anything using some special variables like pi and all. And this is another important difference. Even if you wanted to define some complex number, in MATLAB, when you say 5 plus 3i, it will understand. Again, I is a special character. MATLAB, by default, MATLAB will understand I is a complex. 5 plus 3i is a complex number. But Scilab will ask who is I. So how do you declare this? I is a special character in Scilab. I have to declare I as 5 plus 3. So now it will treat this as a complex number. So pi, this complex term, these are the special characters in Scilab that to be notated with percentage symbol. Okay. For the first time, whenever you create a variable and you try to, as soon as the organizers will share the data, okay, the input data for the afternoon session. What I recommend you, okay, they will, once you have downloaded all the files, okay, maybe you have downloaded whole folder, whatever the way it is being shared with you, like a zip file or an independent file, whatever the format. My suggestion is, if you kept all the input file in the form of a folder, okay, don't copy as the entire folder. What I recommend you, in case if you download the data in one single folder, just you open the folder and access the individual files. For example, let me show you. Um, in my downloads, I have a folder called datasets. Okay, so I have a datasets. So don't copy the entire folder and paste it in your Scilab. Okay, what I recommend you, open the folder and then Control A, select all the files. Okay, all the files. But this is not the, just for a sample I'm telling you, but this is not the folder is going to be, maybe one or two files may be coming from this folder, but you'll get a different set of data that you'll be receiving before lunch. Okay. So these data you have to select individually. Okay, Control A and Control C, copy, and then you cannot directly copy in your using your Scilab console. If it is a MATLAB, I can directly do a right click here and I do a paste command. But here again in Scilab, I cannot directly create a folder by doing a right click. I cannot copy a file by selecting like this. I cannot give a Control C and all. But that option was available in MATLAB. So only you have to navigate using your folder browsers. So you navigate to program files and the Scilab. In Scilab, whatever the folder we have created for CMR FDP, you go inside the right click and paste the individual files. So make sure that your data files and your Scilab files should be in the same folder. Don't keep your data files in a different folder and your Scilab files in a different folder. Your Scilab files and your data files should be in a same folder. So as soon as you receive the file, you copy paste. So when the first time when you may copy paste any files, any data into the folder, whatever you have created, by default, permission is not given by default in any folder you create in the Scilab environment. It will say permission denied. When you try to copy anything, the first time, whenever, as soon as you install Scilab and you try to copy anything, it is first time it will deny. What you should do, the moment it denies, in case if it denies, so what you have to do, you have to give right permission, whatever the folder you have created for this workshop. Okay, so you have to right click that folder, go to properties. Okay, go to properties and go to security. If you go to security, there is an edit option. Click edit. See, already I have given the right permission. That is why for me, in the group or user names, always you have to select users. Okay, in the top, you have to select option users. Under the users, can you notice there is a bold black symbol, black tick for me for the right, bold black tick. Initially, this is not enabled for some security reasons. So you have to give edit, keep the group name as users, and then scroll down, and for the right box, you have to tick this right box and then give apply OK. As soon as you do this, then only all the files you are able to save in the folder, whatever you have created inside Scilab folder. So you may ask, is it a mandatory that I should create my work folder only in this path? Shall I create somewhere in the E drive or D drive also? You can very well create it, but your code will run highly optimized. If you create your work folder in the path where your software is being installed, some slight latency or delay happens if you keep files somewhere in the E drive or E drive comparable to E drive, C drive itself, C drive program files path. So whether you do this strategy in MATLAB or in the Scilab, I strongly recommend you create your work folder in the folder where your software is being installed. In the same folder, you create your work folder file. Having said that, even if you wanted to create your work folder in some other drive also, you are free to do that. But creating in this path, it is highly optimized. Your code will run in a highly optimized manner. That is my recommendation. Okay, once you have enabled the right enabled you have, so now you are ready, your folder is ready to take any input files and to all the programs you can save. So we got some idea about the console, right? We've got some exposure to console. So if like in MATLAB, we have M file, right? M file editor. Similarly, here we got something called SciNotes. So in the top left corner, you can see launch SciNotes. That is the editor. Always the command window or in console, you can use it like a calculator to display some simple calculations. Okay, to whether to make sure that whether your data is correctly loaded or not. Maybe for a quick verification and all, to check the size of the data what you have loaded. For a simple manipulations, you can make use of the console. But if you are going to write a full-fledged coding algorithm or some process, you write from top to bottom. So it is not recommended to write your full code in the console. Okay, like the same rule in the MATLAB also. In MATLAB editor, is not recommended. So you have to write your coding in the editor part. Similarly, here we have the editor called as a SciNotes. So SciNotes is already, it's open for me. Okay, this is SciNotes. For the first time, if you're opening the SciNotes, I would say click the top left icon, or also you can select a file. Okay, open a file. If you wanted to open a already loaded file, you can go with this. Otherwise, directly all the files are visible here. Double click it, it will automatically open your so the moment you open SciNotes, it look like this. Let me your blank SciNote look like this. Always I recommend to start whatever you are going to do the coding in SciNotes. Start with CLC and clear. If you wanted to adjust the font size of your editor or even the console window, what you have to do, you have to click the settings. You can see the tool symbol, right? This tool symbol you have to click. The moment you click the tool symbol, in the left hand side you can see so many options. There you can see fonts. Now you can adjust, increase or decrease the font according to your convenience. Whichever the font size you are comfortable working with, adjust the font size, because the default font size will be very, very small. Particularly as a presenter, I cannot display the thing with a very default. It will be looking like a very small font size. I think the default is 12 size, I guess, but already I have increased this to 24. But still, if you wanted to increase this further, again, you can give the separate font size setting for console separately and SciNote separately. But you have to do one by one. Suppose first I need to set the font size for the SciNotes. First you select this as SciNotes, and here you can choose the size. Also the font size also you can select here. So I have taken already 24. If I wanted to increase that further to 30, I give OK. Okay, now it is the monospace 30 plain. I give apply OK. The moment I say apply OK, now you can see the font size has increased. If you wanted to increase the font size of your console also, this is the console, right? In console also the same procedure. So open the settings, go to fonts, console, select the console. Earlier I have selected 20 for the console. Maybe I choose the same 30 for console also. Okay, now it will look a bit bigger. Say for example, G equivalent to so this font size looks very comfortable for our visualization. So it's whichever the font size you would like to keep for your console and the SciNotes. It's up to you. You can choose the font size whichever you are interested in, comfortable with. So these are the setting the environment. So far, what we have discussed: understand the console and the environment of the consoles, and how to create a new folder as a working folder, and how to change the security options to give a right permission whenever you are doing it for the first time. Because I know that every time such workshops, the first question comes from the audience is, sir, we were not able to copy the files in the folder what we have created. That is why at the beginning itself, I told you, in order to avoid that problem, we could not able to save the data or copy the data. First thing, the moment you created the folder, first you give the right permission to that folder. So then you don't have that issues. And understanding your side notes. And another important difference when it comes to editor, in MATLAB, whenever you write the programs, the program part is divided into two components.
reply.
ரெண்டு மேம் எனக்கு சீரியஸ் சந்தேகமாவே இருக்குது மேம் எனக்கு அவங்க எப்படி தெரியுமா சொன்னாங்க பாருங்க போயிட்டு ஃபர்ஸ்ட் நான் வந்து
Hello.
Yeah, I'm there.
Dr. Anand, sir?
Yeah. Can you hear me, ma'am?
Yeah, sir. Sir, can you please repeat how to make the writable, how to make the files writable? Can you please?
Yeah, sure. Yeah,
because
sure.
sir, I can't, communicate through chat.
Oh, okay.
So, yeah. Okay,
Yeah,
sir.
sure.
Thank you, sir. Thank you, sir.
So whichever the folder you have created, okay, the CMR IT folder I have created, first you have to right click that folder, go to properties. Okay, in the properties, select security, go to edit, and you scroll down. In the top group name or user name, you have to select users, and you scroll down and enable the right option, right, apply, okay.
Okay, sir.
Got
Thank
it.
you.
Yeah.
Sir. Thank you.
Just a few seconds, please. Just
announcement for the participants. So chat window is disabled, and if any participant gets any doubt, please unmute yourself and clarify your doubts, or else you can raise the hand and get an opportunity to discuss with uh, Dr. Anand sir. Thank you.
thank you.
Anand sir, we can't hear you.
Just a moment, sir.
Okay, sir. Okay, sir. No issues.
See, when it comes to editor in MATLAB, whether I have two options. One is to write a script file. Another one, we can write a function file. So we know the difference between script file and function file. Script and function file. Script files are directly executable, right? That is the difference between a script and function. You write like CLC, clear, you define some variable, okay, a B vector, and you just did some operation, out equivalent to A plus B, and disp of out, a simple operation. I have created two vector of equal length. I added the two vector, I display the output. This is a simple script file. Whereas a function file, how do you write in MATLAB? You write with your function keyword and your function name, right? For example, it is a my addition. Okay, my addition. You get two input vectors like A and B, two input vectors. And as soon as you collected the two input vectors and you say like out equivalent to whatever the operation you do inside the function, you define that operation. And we are returning the result out. So your function files are not directly executable. How do you save this file in MATLAB? We have to save this file as my underscore add dot m file, isn't it? My underscore add dot m file. So in your script, instead of writing your actual regular code here, CLC clear, just you define the two variable A and B vector, and simply you can call your function my underscore add. You pass your input variable. It is going to return the sum of the two vectors. What is the key point here is your script files are directly you can run through your run button. So this is your execution button look like this. Directly you can click the execution button. But for a function file, if you directly run the, you cannot directly run the execution button. If you try to run this file as an execution, it will throw an error. So no function file should not be directly, you should execute it. Your function file should only be called. A function can be called, your function file should not be executed directly. Same way applicable in Scilab also, but in Scilab, what is the major difference between the script file and function file is, in MATLAB, whether it is a script file or say I have saved this script file as day1, okay, day1 underscore exercise 1.m. Inside day1 underscore exercise 1.m, I have called the function. So inside this .m file, I have these lines of code, right? So inside day1 underscore exercise 1.m, I'm calling the function file my underscore addition a comma b. So I'm calling another function file. Okay, it's calling the function. So your function file as well as your script file, your extension is same, which is .m in MATLAB. But in the Scilab, there is a difference. Okay, that is another major difference in Scilab. Understand, in Scilab, all your script files having an extension .sce. .sce. That means I'm going to introduce you shortly, maybe after the coffee break. Once we finish the basic discussion on the vectors matrices, then I'll discuss about how to create a user-defined functions in Scilab, as similar to MATLAB. But only there are very few differences are there. For example, in MATLAB there is no n function, but here I have to give n function in Scilab. N function keyword. There is no n function line in MATLAB, but here I have to give n function. Like very mild difference. But the major difference here in MATLAB, whether it is a script file or it is a function file, we have the common extension, which is .m. But here in Scilab, we don't have a common extension .m. So whenever you write function in Scilab, we have an extension called SCI. Okay, for script file, the extension is SCE, and for function file, the extension is .sci. That's a major difference. Number one, the naming the file extension, that is a difference number one. Okay, difference number one. Another important difference when compared to MATLAB, why I'm always comparing with respect to MATLAB, the reason is we know that Scilab is an alternative to the MATLAB. Okay, we even in the title of the FDP also, it is an open source alternative to the MATLAB only. So definitely it's 100%. It's a excellent tool, excellent alternative to the MATLAB. There is no doubt. Once you know the differences alone, if you have already MATLAB knowledge, okay, migrating to the Scilab is just hardly within a week. You can easily migrate. You don't need to separately sit and learn for Scilab preparation. It is a very smooth migration, easy migration you can do. I'll tell you, once you are strong in MATLAB and comfortable working with Scilab, migrating to Python, it's not a big deal. Just 2 weeks of time only it will take. Easy. It's very easy. It's a very user-friendly language, but yet powerful language. Once you started using Python, you will never look back to MATLAB and Scilab. I'll give you 200% guarantee because I have experience personally. My first 10 years of my career, I have extensively used MATLAB. First 10 years of my career, MATLAB and Scilab. The next 10 year, I just moved my journey from MATLAB, Scilab to Python, or both are open sources to analyze the data for the numerical computation and scientific calculations. Both are open source, Python and R. These two software plus one more software, SAS, which is a proprietary licensed product. This is SAS. These three packages are rolling the entire data science and artificial intelligence fraternity across the globe. Out of these three tools, Python dominates, I can say 80 to 85%, and R is around 20%, hardly R. And SAS being a licensed package, it's very much used only in the clinical research company. CRC. People used to say CRC. Mostly the drug development, pharmaceutical related company, they use SAS. Because there was a restriction by Food Drug Administration, FDA of USS, and some European drug administration. They have standard that unless otherwise the data has been validated using the SAS package, then only they'll pass the approval for the new drug, whatever the analysis. That was the old time. But in the recent time, in the last 4-5 years, FDA and worldwide organization, they have relaxed the norm. It is not necessarily that you should analyze the data only with SAS. Okay, they have relaxed the norm. Even you can use the open source package like Python and R. It is acceptable. So that is a good news for the clinical research companies. They don't need to spend, because when compared to MATLAB price, the SAS price is, I can say, at least 5 to 8 times costlier than MATLAB. So this is a very so expensive tool to analyze the data. Whatever the analysis is possible in SAS, everything is available in R programming and Python programming. So this is additional piece of information. So for the last 10 years, I'm predominantly using Python and R. How this journey is possible? Because initially, my first 10 years, I worked with extensively on MATLAB and Scilab. So migrating to Python and R is not a big deal for you if you have a very good exposure in MATLAB and Scilab earlier. Hardly it will take a maximum, not more than a month. Easily you can master Python. Okay, the first difference is the naming the file .SCE extension, .SCI extension. So maybe today you remember, maybe next week if I ask you, you may forget, you'll get confused. Okay, for script it is SCE, or for function it is SCI. It will very quite natural, it will fade away from our memory. So basically, I just give you one shortcut to remember this easily for your lifelong. Okay, we know that script file is directly executable file. Your function file cannot be directly executable. Your function can only be called, right? So since a script file is a directly executable, so E stands for executable. Please remember in a short manner. You will never forget throughout your life. So for the script file, it is .SCE extension. For function file, the another one, which is SCI extension. So whenever you have a dilemma, it is SCI or E. This is a shortcut to remember it. Script file is an executable, so E should come for script file. Number one difference. Number two difference, in MATLAB, directly I can call the function. Directly I can call the function. But in Scilab, you are not supposed to call the function directly. I have one intermediate step before I call the function. That means first I should load the function in the memory, in the workspace, that is a variable browser, then only I can call. So there are two-step process in Scilab. One is loading followed by calling the function. Load and call. Whereas in the MATLAB, you can directly call without loading. So we have one extra step. So the loading is done by calling a function called exec. Okay, within the quotes, whichever the function you are going to call, first you have to load that function in the memory using exec command. For example, this is the function I'm going to load. I have to say my_add. This will load into the memory, and then you can call, followed by you can call my_add. You can pass the variable a comma b. So these are the two key differences between MATLAB function definition and Scilab function definition and calling. The way in which calling the function, in Scilab we have one extra step. We have to load the function, then only we should call. Okay. So these are, I have mentioned almost the major differences between MATLAB and Scilab. I highlighted in the first 1 hour itself. If at all, if any other difference is there, I will down the line, the subsequent session, I will let you know. Almost all these are the major differences I highlighted. Almost all major differences. Okay, now we'll do certain exercise on vector definition and matrix definition, indexing.
Sir,
Any question? Yeah.
yes. Is there any major difference between Scilab 6.1.0 and 6.1.1? Because
Nothing.
I have 6.1.0.
No, nothing. Even
So
you
I
can
can
work with the 5 dot series also. You can work. Not major differences.
no any major difference. Okay,
No,
sir.
no,
Thank you, sir. Thank you.
no issues.
I have already Scilab 6.1.0, sir, and
Hmm.
I have worked on that lab
No
little
issues.
much. Okay,
See,
sir. Okay.
see, always immediate lower version is highly stable. That is the rule.
Yes,
Any
sir. Yes, sir.
software, see, any
Sim-
software, that is a logic. Even people
Even
will
in
be
MATLAB also, sir.
the immediate lowest version you can confidently work because that will be
Yes,
more
sir.
stable than your the latest version.
Yes, sir. Right, sir. Right.
Almost
Okay, sir.
any packages, any application, the latest versions people called as the beta versions, because they don't know when the bugs will come, when they have to fix, when they have to optimize and all. Based on the
Yes.
feedback, being an open source, the people in the open source community, they'll give the feedback and they try to fix the bug and optimize the code. So you're working on 6.1.0 means you are more safe. Don't worry.
Okay, sir. Okay. Thank you, sir.
Yeah. So let us start working with because any scientific calculations when we work with, okay, the vector algebra is the basis foundation. So let us understand maybe some of the topics, whatever I'm going to discuss for the next 15 minutes or 20 minutes, whatever maybe it looks sounds silly and sound familiar for you. Okay, but just assume that even if one or two candidates were not aware of this, for the benefit of those candidates also, it could be useful. Okay, if you are already aware of, make utilize this next 15 minutes as just a quick recap. So the way you define your row vector is same as MATLAB, as I told you, right? Either you can use a comma separation or a blank space. There are two options. Whenever I'm defining a row vector, I can define, see, this is my V1 is my row vector. I have defined using a comma separation, or simply you can use a blank space. Both are allowed. So the same procedure in MATLAB also the same procedure. I have defined a vector and displayed the vector V1 vector. Also, can you see the commenting differences? MATLAB, we have a different commenting percentage, but here we use a 2 forward slash. When I use a 2 forward slash, that is meant for non-executable line. You can write your comments. Okay. As much as possible, you try to do all the exercises are very smaller exercise. At least I can tell you maybe till tomorrow evening. The moment we navigate the exercise during the day 3 and when we move to machine learning, the length of the coding slightly increases. Okay. Till then, till the time, whatever the codes and the exercises we are going to do, hardly it won't exceed each and every part. They don't exceed like 4 to 5 lines. So my strong recommendation is try to do the steps whatever I'm doing it parallelly. You try to do it in your system by minimizing a window. Okay, I think you can keep the window one side to visualize this, and another side you can minimize your Scilab window, reduce the size of the Scilab window, and that Scilab window you type it. uh, See, since many of you Scilab, you may be using this for the first time users, at least one full day you put your hand and you type on your own, you'll get more confidence. And so that is the reason generally I used to share all the codes at the end of the day. Sometimes people ask me, can you please share this coding at the beginning, because if I share the code at the beginning, you never intended to type. So what happens, simply you just execute and see the result, but the learning will not happen. If the real learning has to happen, at least you few exercise, when you start typing it, you'll gain more confidence. So that is the reason. So definitely you'll get all the files at the end of the day. So don't worry, all the exercises whatever you're going to see are very few lines of code. It is easily you can do it parallelly. So if it is like a one single algorithm you have written in one side notes, okay, you can after saving the file, you can enter this execute button. Okay, you can directly enter this execute button. Uh, since this exercise, I have so many subdivisions. Since in this one single exercise, I have so many subdivisions, so I'm not going to execute the full script at once. Okay, basically it is a script file. It is not a function file. How do we understand it is not a function file? Because we don't have a function keyword, right? So it starts with, whenever the coding starts with clear, definitely it is not a function. And moreover, there is no function definition here. Rather, I will show you a function file. For example, look at this is the function definition looks like. Okay, we'll come to this after the break. Okay. Um, I have defined a row vector. So this is a line by line execution. I right click, evaluate selection with echo. Even in MATLAB also we have this facility, evaluate selection. Whichever the lines you have selected, only that part it will evaluate. When I do evaluate selection, go to your console and see, this is a row vector what we have created. So the moment we created a vector, the first thing we very commonly use to get the length of the vector, right? That is very common, getting a length of the vector. The length of the vector 5. We have 5 entries. We should know how to do the indexing. That is a basic. You should know how to index the vector, how to index the matrix. That is a fundamental. Whatever the applications, the scientific applications you are going to develop in Scilab, this is a very fundamental how to access the data through that variable. Okay, so through V1 vector, if I wanted to access the data, the first entry of the data starts with index 1. Index 1. This is one common characteristic between MATLAB and Scilab. The starting index is 1. Starting index is 1, both for MATLAB and Scilab. Now I'm giving you additional piece of information for you for future. In case if you learn Python in future, Python starts with 0 index. MATLAB and okay, this is an additional piece of information. Just keep it in mind. So throughout the session, some key information related to Python also I'll tell then and there. Maybe you may think it is not relevant. So why you are telling about Python during this? Because I told you for the sake of FDP, we are learning Scilab. Okay, no issues. You learn it very well. You learn. It's a must learning it because it's a very good alternative to MATLAB. But in a longer run, your research is going to be highly focused on artificial intelligence and machine learning. My strong recommendation is, as soon as you migrate to Python, it is a you will enjoy the maximum benefit of it. For that, the futuristic aspect, I'm giving some few important inputs regarding Python also then and there. Okay, so the starting index is 1, and another unique difference between MATLAB and Scilab here is the last index. The last index, for example, the sequential indexing. Whenever you wanted to do the sequential indexing, when I say 1:3, it is access the data from the first index to the third index. First index to third index. And if when I wanted to fetch 295, typically how do we fetch 295? So V1 parenthesis. So the index of 2 is 3, right? 3 colon. Okay, 3 colon. In MATLAB, I can say end, till the end. But in Scilab, we don't have this end keyword. Instead of this end keyword, I have a dollar symbol. This is another difference. So if you are maintaining a notes for this FDP, whether you are writing the notes parallelly or you are recording it digitally, whichever the format you are record, I would advise you create one fresh page. You can make it divide into 2 columns, MATLAB versus Scilab. In that page, you just mark the important key differences. It will be like a quick reference. Always you can refer it for a quick, like the beginning. At least from the beginning, I have given at least more than 10 differences. Okay, so this is the instead of end to access the last index dollar symbol. Whenever I use this dollar symbol, 3 colon dollar means 295 it fetch. Whereas in the MATLAB, okay, instead of dollar, I use end. But in Scilab, it will say syntax error. Okay, Scilab will not understand this end keyword. So we replace that with a dollar symbol. So this is a vector indexing. So this is a row vector. So whenever I have a size function, length function is going to give you the total number of elements in the vector. Always you can use the size function to get the number of rows and columns. Being a row vector, it is a one row, and I have 5 elements, isn't it? One row, 5 column. This is like a, you can consider this like a 1 cross 5 matrix also, or single row matrix. Single row matrix with 5 column. Okay, this row vector can be treated as a single row matrix with 5 columns. Okay, now we'll see how to define a column vector. Now you can see the difference between the definition row vector and column vector definition. We use semicolon here. Semicolon. So using a semicolon, if you use a blank space or comma, it will create a row vector. Instead of blank space comma, if I use a semicolon, it will create a column vector. Now I define this column. Okay, any number you can use to define this column vector. Let me keep this column vector as V2. The indexing rule is same whether it's a row vector or a column vector, the same indexing rule. For example, from the third record till the last record, I want to fetch. Third record till the last record. That is 1, 3, minus 7. It's the indexing, right? The same way, whether it's a row vector. Remember, whenever you operate two vectors, for example, if you wanted to make an addition, make sure that the two vectors should be of consistent dimension. I cannot add a 1 cross 5 vector with a 5 cross 1 vector. Either both should be a row vector of equal length or both should be a column vector of equal length, then only it is possible. Either you can transpose the second vector and add, or you can transpose the first vector and add. Okay, this dash symbol will transpose your vector row to column and column to. In the first case, what I did, I'm transposing the second vector, which is column. I'm transposing to the row vector, and then I make the addition. In the second case, what I'm doing, I'm transposing a row vector to column, and then I make addition with V2. So whenever you wanted to do an addition operation or a subtraction operation, both vectors should be of same dimension. Because in many scientific calculations, we encounter vector addition, vector subtractions, vector multiplications, matrix multiplication, and so on. So this is about row vector and column vector, and about the transpose. Okay, I think I will halt at this stage. Okay, we will continue with this. What are all the different vector operations and matrix operations, and the matrix formulations, how it is, what kind of application we can connect with by learning these vectors and matrices. After the break session, I will share it with you. Some interesting applications like eigenvalue, eigenvectors, SVD, singular value decomposition, covariance matrix. We have some interesting applications. So you will also learn how these applications is going to be beneficial in to the context of data transformations or processing. So that context also I will tell you post break session. And if you look at the agenda, after understanding this mathematics formulations about the vectors and matrices, I will introduce the control flow structures. The control flow structures in MATLAB, we have a for loop, if condition, a while loop, and all. So that also we'll be discussing 11:30 to 1 o'clock.
वहाँ साइन करना है ब्लैक नहीं ब्लैक है क्या ना रुको रुको दे रहा हूँ फोटो ही लेना
Hello, sir. Hello. Sir, screen is not visible and your voice is not audible.
Sir has completed the session.
Yes, sir. Okay, then we will be sharing the feedback link for this session shortly. Uh, yeah, please fill the feedback form just before the second session starts. Thank you all.